Hey guys, welcome to J.T.Engineering. In this video, I'm going to be starting a project that I've wanted to do for my entire life. I'm going to start building a live steam engine. This engine in particular is a Fitchburg Northern made by Allen Models. It's a 2.5-inch scale, and for those of you that may not know, 2.5-inch scale is roughly 5th scale, but this is considered a narrow gauge engine. So even though it's a little bit larger compared to maybe a 1.5 or a 1.6 scale engine, it's roughly the same size because the narrow gauge engines were teeny tiny in real life. Well, at least the moguls were. So in this video, we're going to be starting to build this. This is going to be a multiple part series. This is going to take me a few years to complete, I think. So this is part one of many. As you can see, this has been partially machined. The drivers are all done. The frame is complete. The cylinders are mostly complete, but it is far from running. So in this video series, we're going to be taking this locomotive, we're going to be building it. I'm going to be trying to show you guys how I'm putting things together. Again, keep in mind, I have no idea how to machine. This is kind of just to be able to prove to myself that I can do this and to show anybody that's thinking about doing this that if you are a total beginner, you can start and build a live steam engine all on your own. So for this video, we're going to start with the tender. The tender, I think, is probably going to be the easiest thing to start with, where the parts aren't so critical. So if I make mistakes on the tender, it's not the end of the world. Then I can kind of build my skills and move towards the actual engine itself, where things are a little bit more crucial and the part tolerances are going to be a little tighter. As you can see, the tender is already made. This was something that came with the locomotive when I bought it and is just sitting on the tracks. So for this episode, we're going to be building the Fitchburg Northern tender trucks. Why don't we go ahead and get started?
Before we get started, let's take a look at how I got this project. I found this engine on a Facebook page for Allen Models Fitchburg Northern builders. The owner of this engine was in Louisiana and was nice enough to crate it up and ship it to me. The locomotive project showed up at the freight dock and weighed 700 pounds. This project came with all the castings needed to complete the locomotive and some partially machined loose parts. Unboxing this thing was a bit overwhelming. It just looks like a bunch of metal in a box, but I knew with patience and time I would be able to someday make this thing roll down the rails. Now onto the tender trucks. The first thing I needed to do was take a look at the tender truck plans and get an idea how I was going to build this thing. The tender wheels had already been machined, but everything else was either a casting or just steel stock. Looking at the plans, I figured I would start with the studs that hold the trucks together. There are 8 1/4-inch studs and 16 3/16 inch studs that need to be built for the 2 trucks. I made the studs out of some steel rod I bought from the hardware store. I chucked the rod up in the lathe and chamfered the end of the rod with the file to accept the threading die easier. I then marked where the threads would stop. I came in with the tailstock die holder and created the threads. I then parted it off to length, flipped it around, and did the same operation on the other side. I probably didn't have to use the lathe for this, but it gave me some time to get better acquainted with this piece of machinery, so I'm really glad that I did. You can see here on the 1-to-1 plans what the studs do. They really do hold the entire truck together. We'll see this a little bit better later in the video. I knew I was going to paint this truck black, so I decided to experiment with this Jack's metal blackener. I just cleaned the parts well with acetone, dropped them in the metal blackener for about a minute, and then rinsed them with water. This wasn't completely necessary since the trucks are going to be painted anyways, but I figured experimenting with these parts was harmless since most of them won't be seen anyways. I repeated the exact same operation for the other smaller 3/16 studs I needed, and then we could move on to the journal boxes.
All right, now that we have all of our studs made, the next thing to do is the journal boxes. You can see in the drawing that it fits right here. The journal boxes are what support the axles. This hole right here is for the bearing that'll eventually fit in there. So we're going to start by surfacing this down, and this will be our reference surface, and we'll kind of work our way around until the part is fully machined, and then at that point we can put together our axle shafts. The reason I wanted to do the journal box first was because I want the bearing to land right in the middle of the journal box. This way I know that there's going to be adequate support from the journal box. This drawing in general, let me show you. So the actual plans call for bearing brass, but instead of bearing brass, we're going to be using ball bearings because I don't want to have to deal with that. So these ball bearings will at some point get fit into the journal box.
I dropped the journal box casting on the mill and used the dial indicator to make sure it was as flat as I could possibly get it in both the X and the Y axis. Castings are pretty rough, so indicating one of these in was a matter of reducing the difference in height from one side of the part to the other. The needle flies all over the place because the casting isn't perfectly flat, so getting the needle movements to average near 0 was good enough for me. Once it was indicated in, I used a shell mill to mill my first reference surfaces. These journal boxes were plenty fat on material, so I knew I was able to take it down to the point where I had a nice surface without any inclusions. Once that was done, I decided to do a top and bottom of the part. Since I had a nice flat reference surface, I could place this on the back of the mill vise, providing a pretty square surface in one dimension. To get this square in the other dimension, I indicated this in the same way I did with the back. I then milled away enough that I had a nice surface to work with. I then flipped over the part and did the same thing on the other side. I was careful not to mill too much away here though. These parts needed to be 1.625 inches tall, so I pulled the part out of the vise, measured it, and then figured out how much material I needed to remove to hit my dimension. I then put the part back in the vise. I then touched off on the part with the cutter, marked a 0 on my coil DRO, and then it was just a matter of milling down to the final dimension. I also cleaned up the casting around the mounting bracket for the journal box lid on this step. I just did this using the old micrometer. Once that was done, I pulled the journal box out and checked my dimension. It looks like on this part I came in 1/1000th over on dimension here, which to me is pretty good. Considering this is the first thing I've ever made on the mill, I'd say I'm off to a pretty good start. I then repeated the same thing on the other 7 journal boxes. Now that we had 3 reasonably true surfaces, we could bring the ears of this part down to final dimension. To do this, I just side milled the sides down by taking light passes. I then flipped the part around and did the same thing on the other side, but to make sure all these steps were repeatable, I used an end stop set up by a magnetic base so the parts could be easily located. Once the width of the ears was correct, we could drill the mounting holes for the studs. To do this, I used an edge finder to find each edge. I then centered the DRO in the middle of the part and zeroed it out on that axis. The stud should pass through these little slots on the sides of the journal box. To center it on this feature, I just used the micrometer once again to get it to line up. This isn't a critical dimension, so using my eyes to line this up worked out just fine. With these are now zeroed, I could drill my holes accurately. I drilled all the way through these parts, making sure that I didn't hit my vise or the parallels that were holding the part up. The next dimension, however, is critical. The back of the journal box needs to be 0.75 inches away from the center of the holes that we just drilled. This is why I zeroed the DRO in that last step. For this, I was using a 3/4 inch end mill and was going to take light passes and side mill the back of the part down to final dimension. To get the correct final depth, we have to do some math. The edge of the part needs to be 0.75 inches from the center of the holes we drilled. If we set 0.75 inches on the DRO, this will be where the center of our cutter will land. Since I'm using a 3/4 inch end mill, we will need to add half of that to 0.75, and this will be the value we mill down to the end dimension. After taking a few light passes, I brought each of the 8 journal boxes down to final dimension on the backside of the part, and now we could start working on the hole for the bearing to land. I used an edge finder to center the part in the vise. However, not all the edges on the back of the part were machined, so I had to reach down and center the part from the machined surfaces on the ears. Once this was done, I started boring out a little pocket with a 5/8 inch end mill. There's a nut on the end of the axle shaft that will live in this little pocket in the journal box. Now I was able to start working on the main hole for the bearing. To do this, I removed most of the material with a large drill bit, and then came in with a boring bar and bored the hole to final dimension and depth. I creeped up on the final dimension using a snap gauge and then measuring the gauge with a micrometer. I didn't nail any of my dimensions in this step, but that's part of the learning process and I think they should work fine anyway. Once this was complete, we had just a couple small things left to do. I used a file to flatten out the cast surface on the journal box where the lid would sit. I didn't see a reason in spending a bunch of time setting it up in the mill. Once that was done, I drilled the hole to mount the journal box lid and then drilled each journal box lid to accept the pin. Now we just install the journal box lid, do a little bit of filing so they fit right, and now we have 8 adequately machined journal boxes. Considering these are the first parts I ever made on my mill, I'm extremely pleased with how they came out. They may not be perfect, but I learned a lot and I feel confident moving on to the other parts. Next, I decided to start work on the bolster. To start, I slapped it in the mill vise and made sure it was level in both dimensions. Next, I needed to make sure this part was centered under the spindle. I needed to drill a hole and machine a dish in this part where it will sit on the truck frame. To do this, I took my indicator and set it so I could rotate it around the part. Doing it this way, I was able to move the X and Y axis to reduce the movements in the needle. When I felt it was centered, I zeroed my DRO. Next, I started by drilling the hole. This is where the truck pin will eventually pass through and connect to the frame. After that was complete, I used a shell mill to bring it to total thickness and the dish down to final dimension. Now it was time to start working on the countersunk portion of the dish. The hole I drilled wasn't large enough for the boring bar to fit, so I used a 5/8 inch end mill and plunge cut it to final depth. I then had enough room to get a boring bar in and bore out the rest of the dish. I had to remove quite a bit of material, so this did take some time. Since I had zeroed my DRO in both dimensions in the last step, I could calculate where I needed these features on the end of the bolster to land. These slots are where the bolster will ride in the end cap and keep the trucks aligned. We'll get a better look at how this assembles later in the video. Once the bolster was finished, I decided to take a break from the mill and do some work on the lathe. It was time to machine the axle shafts. The tender wheels were machined already by the previous owner, but the holes were inconsistent by a couple of thousandths, so I measured each hole and machined each axle shaft to accommodate that specific wheel. I figured that was still going to be faster than machining all new wheels. I started by facing off the end of the part. The axle shaft has a few shoulders, making this part deceptively difficult, at least for me. There are 4 shoulders on each end of the axle shaft. The first shoulder gets turned down to accept a 5/16 24 thread, where a nut that will retain the bearing will live eventually. The next shoulder is where the bearing will sit on the axle shaft. This dimension was also very important that I hit. The shoulder after that is just used as a spacer, but then the last shoulder is where the wheel will get Loctited in place, and each of these shoulders is specifically machined to accommodate the specific wheel for that side. On each of these dimensions, I used my DRO in combination with my micrometer to creep up on the dimensions. All of these dimensions are super critical, and it was important that I took my time and hit them as best as I could.
Yeah!
When the shoulders were finished on the one side, I slid the stock out and then marked the end point of the final shoulder on the other side using the DRO. This dimension is extremely important because this is what sets the gauge of the wheels. I'm building my locomotive to 7.5 gauge, so the measurement from the back of each wheel is 7.2 inches, and this shoulder is what sets that gauge. Once I had the back of the shoulder marked, I flipped the part around, did some math, and parted the shaft off to final length. After this, I just repeated the same set of operations as I did on the other side. Once those operations were done, I did use this opportunity to just polish up the shaft a little bit, and after that, we could kind of put everything together and show you guys how it was going to assemble.
Alright, we are finally to the point where I've made enough parts that I can kind of show you guys how this is going to go together. So the first thing is the wheels. I know you guys didn't see me make the wheels because they were already made. So I decided to just use what I had. This one I kind of just painted. I'm going to experiment with polishing the outside of this. You'll see here in a minute. We've made our frames. Well, actually that's not the frame. Not really sure what that's called. Leave me a comment and let me know. We've made our 5 axle shafts. Wait, 5 axle shafts? That's right. I made 5 of them. This is one that I scrapped. This was the first axle shaft that I made. All the dimensions are pretty close, but then I scrapped it right on the very last operation. And as you can see, that wheel has way too much play. But this is a good time to kind of talk about why I'm making this YouTube channel and what this series of videos is going to be about. Look, as you guys know, I have no idea how to machine. This is all very, very new to me. Look at this progress, though. This was my first axle shaft. The threads are pretty good. The dimensions are eh. The surface finish is absolutely trash. But as I made more, I worked my way up to this. And this axle shaft, all the dimensions are right on. The bearings press on. The wheel's going to be a nice fit. I'm very happy with that. I'm all about learning here on this channel. And under the same banner, I'm all about showing you guys my mistakes. And I'm sure there's going to be a lot of them. But anyways, you can see that I have learned a bit in this process. And I'm okay with scrapping parts because that means that I'm learning and making things better. Anyways, we'll go ahead and move along. So we've got our thingy-magob. We've got our axle shafts. We have our wheels. You have seen us make the journal boxes. We've got those. So we'll go ahead and place these here so they look nice for the video. Look at that. Wow. So we have a couple more things that we need to make. The first thing we need to make is going to be the frame. And you can see that I already have these parts that are bent and they're pre-drilled. I'm not sure how accurate the bends are. We also need to kind of make these spring pads. These are pretty close to correct dimension, but I do need to machine these down. The springs for the suspension will sit on these pads on the bottom. The next thing that we need to make is our bolster ends. So we'll go ahead and start with that. I think we're going to do that next. But anyways, you can kind of see how this goes together. So as far as the journal boxes go, they'll mount underneath the frame here. And then you can see inside the journal box, there's a recess for this nut to go. And the way that this will assemble is the bearing will slide in here. And then we'll do the same thing on the other side. And the wheels will be Loctited onto the shaft here. And it's just going to ride pretty much just like that. So we'll go ahead and keep machining, but I wanted to take a second and show you guys that we are actually making progress and I'm not just making parts for the sake of making parts.
These bolster ends were actually the hardest thing for me to machine on these trucks for some reason. There was absolutely no extra material on these castings, so I had to make sure that everything was done correctly. To start, I indicated them in level as I have done on all the other previous parts. Finding a reference surface on these parts was tough, so I touched off on the front of the part and removed only enough to get a solid reference surface. I then zeroed the DRO and then did the same thing on the back, and after that pass was complete, I could then find the center line of the part based on the two machine surfaces that I had just made. This was important because there are slots on the top and bottom of the part smack in the middle of where the frame will mount. As I said before, there was almost no extra material to work with on this part, so I removed as little material as possible off the top, basically just removing the flashing from the casting process. I then zeroed my quill DRO and started milling my slot. The slot depth is different on each side, so I was careful to make sure I was going to the correct depth. You can see me machining that slot to final dimension here. Once I had that pass done, I flipped the part over and then repeated the same process on the other side. The dimension between the slots was also critical because this is going to set the spacing for the truck frame. I was able to hit my dimension pretty easily by only removing as little as possible as I could. There was really no room for error in these parts. After the slot was created, I could mill these little support things down to final dimension. I have zero idea what these are for, so if you know, leave me a comment under the video description below. The end dimension of these little support thingies were referenced off the center line of the slot that we just made, so this was a good time to do this step. I now knew where the center line of the y-axis was, but I didn't know where the center of the x-axis was. To figure this out, I did the same thing as I did with the y-axis. I just touched off on the ends, removed as little as possible, zeroed my DRO, and then did the same thing on the other side. With the center of this part found, we could now drill our holes at the proper spacing. These holes is where our 1/4-inch studs will get placed to hold our frame together. So getting the part centered in the mill and getting the hole spacing correct was absolutely crucial. This next step was the most difficult part on the entire tender trucks, milling out the inside of these bolster ends. The inside of the bolster end is where the bolster will ride up and down inside the slot. It sits on top of springs, and as it goes over bumps in the tracks, it acts as suspension, so getting the slots in this right is important to make sure that it tracks well. However, there are no dimensions to help locate this hole, only the final dimensions of the inside of the slot, so I needed to figure something out. The way I worked around this was I milled away the flashing from the casting process until I just barely came in contact with the actual casting. I did this on all 4 edges and came up with a 0 on my DRO that would be right in the center of this machined opening. I then did some math and wrote down a list of coordinates on a piece of paper corresponding to all the final depths of each corner in each axis. I then worked my way around the part, milling down to those final numbers on the chart. This seemed to work out pretty well. Luckily, I only needed to do this process 4 times. However, I needed to use a 1/4-inch end mill to make sure my corner radiuses were correct to the plans, and I couldn't get all the way through the part. So I had to use a file to remove this little step in the middle where I couldn't reach it all the way through with my end mill. These parts were a total pain in the ass, but I learned a lot making them. I did scrap 2 of these, and I had to order a couple more. The first one I scrapped early on. I didn't get the part fully level in the vise, and I also milled down way too much. This is where I learned there wasn't any extra material to mess with here. The other bolster ended up getting scrapped because it came loose in the vise while trying to machine one of the ends. I scrapped enough parts on this build, I figured it was just time to keep a scrap bin, maybe as an offering to the gods of live steam. I kinda thought that maybe keeping some of these parts and recasting them into something else in the future would be pretty neat, maybe like a new smokestack or something, because the one that came with it is super lame. So maybe one day these reject parts will get repurposed into something useful later in their lives. I took my bolsters outside into the J.T.Engineering paint booth to get a couple coats of paint. At this point, I also decided to paint my wheels. You can see that I just taped off the part of the wheel that I wanted to leave as bare metal. I was now ready to assemble the axles. To do this, I just put a shitload of green Loctite on them and slid the wheels onto the machined surface. Once the Loctite had cured, I then polished them up in the lathe, stepping my sandpaper grits up from 150 to 800. You can see in this shot how big of a difference this really made. I did have footage of me polishing these in the lathe, but they got lost somewhere. After the wheel sets were made, I Loctited the bearings on and installed the retaining nut with Loctite as well. Can you guys tell that I'm a big fan of Loctite yet? I really love this stuff. Before final assembly, I decided to give everything a couple coats of paint. You can see in this shot my spring perches are getting painted. I didn't end up machining them since they fit just fine, but I did use my bench grinder and a file to knock any imperfections off. With the paint cured and all of my parts made, we could finally get to assembling our trucks.
All right, we are ready to put together our truck frames. So we've got our bolster end, we have our journal boxes with the lids just kind of cotter pinned in place. Let's talk about the frame here for a second. When I bought this steam engine, with the castings I got, the previous owner or somebody at some point had already made these truck frames. But if you put them on the one-to-one plans here, you can see that the bends aren't really in the right spot. The profile's a little bit off. And when you kind of put them together, you can see that they're not, I mean, they're okay. But rather than me spending a bunch of time trying to relocate these bends, which would be pretty difficult, I decided to get rid of them And I went on my nifty little computer and I designed some laser cut and CNC bent truck frames. I got these from Send Cut Send, and this is going to be the last truck that I've assembled, and I've got to say I'm pretty impressed with it. So the way this is going to go together is the bolster end will go in here, the journal boxes will go in here, it'll all get bolted together, and we're going to see that right now. I have found the easiest way to put this together is to start, first of all, by putting the large studs in. So we'll go ahead and slide these in, just like so. Stud number 1, stud number 2, stud number 3.
I first installed the 2 larger studs into the bolster end, and then I put the frame pieces on top of them. I did put the nuts on, but I didn't tighten them down quite yet. If I had tightened them down, it would have made getting the journal boxes in place so much more difficult. Once the larger studs were installed, I could mount the journal box with the smaller studs. Between the frames not being totally perfect and my below average machinery skills, the holes didn't exactly line up. I had to run a drill through a couple of them to remove just a little bit of material, but once I had my journal boxes installed, I removed all the nuts and then I applied some red Loctite and tightened everything down. With the truck frame assembled, I gave the whole assembly another couple coats of paint. I really want to make sure this paint on these things lasts as long as possible.
Well, I think we can finally say we are done building these trucks, and we can move on to the final assembly, first time for the last time. So we're going to need our frames. Of course, we're going to need our axles and wheels. We're going to need our bolster. We're going to need 4 springs for the suspension on each side and the spring plates. So having no idea how to do this, I think what I'm going to do is I'm just going to kind of slide these on here like so. 1 on each side. There we go. And then the bolster plate will slide in here, so I might have to kind of, and then it should, boom, just like that. So we've got our bolster in. That's pretty good movement on that, I would say. So now we'll go ahead and we'll put our springs in for the suspension, and this is the part that I don't know how I'm going to do because these springs are stiff as fuck. Okay, so after about an hour of messing around, I think I finally figured out the best way to get these springs in. I have been hit in the face a few times with these springs, and they go flying across the shop, so definitely wear safety glasses when you're doing this. So in the inside of this bolster, you can see that there's this little spring foot, and the spring pad also has them. So what I've been doing is to start off, I flip the truck over so the bolster is on the bottom. I take my springs, and I'll just put the foot of the spring right on that little pad. I'll do the back 2. I'm trying to do this so you guys can see this on camera. And then I'll take the back 2 indentations for the spring and set the pad on top of it. And then I can kind of just slide it up in there and push it into place. Just like that. Ah! See? That's what I'm talking about. Wear safety glasses, kids. I'm wearing safety glasses, by the way. I've already gotten hit in the face twice with these springs.
To get the front 2 springs in, I used a piece of plywood to just compress them enough to get them to stay underneath the bolster, and then I worked them in with a flathead screwdriver.
There we go.
And just like that, we now have 2 adequately machined and hopefully functional Fitchburg Northern tender trucks.
And just for shits and giggles, why don't we set the tender body on? See how she looks. Oh, that looks awesome. All right, we dropped the tender body on. The whole point of tender trucks is to be able to roll the thing around on the rails. So let's give it a little roll test after all that work. Oh, yeah. That's pretty smooth. This functions way better than I ever could have imagined. I'm very proud of these. Effortless. These are excellent. Look at that. Very cool. Those turned out super nice. Oh, not off the end of the table, please. Well, guys, I think that's it for this video. Thank you so much for watching. If you want to follow along with the rest of the Fitchburg Northern build, make sure you hit that subscribe button so you know when I drop another video. These tender trucks turned out way better than I could have ever imagined. I knew absolutely nothing about machining going into this. I scrapped a lot of parts, but I also learned a lot. And at the end of the day, I am very happy with how these came out. In the next video, we're going to be building the frame for this tender. As you can see, there is no frame. The trucks are just sitting on plywood blocks. So if you want to check that out, feel free to hit subscribe. Until next time, happy railroading, my friends.